Welcome back to Mr. Vaughn's classroom, where math is made easy. Today we're looking at Unit 6, Introduction to Quadratic Functions, Lesson 15, Vertex Form. We've previously discussed factor form and standard form, and today we're looking at this third form called the vertex form. The learning goal today is to find out about this. And the main thing is we want to be able to notice that it is in vertex form and then know exactly how to pull out the x and y coordinates of our vertex. We have two learning targets today. These are the skills they're going to expect you to know for your test. At the end of the lesson, we will come back and review these to make sure that you've learned everything you need to. Learning target number 1 says you can simply recognize the vertex form of a quadratic equation. They expect that if you see a quadratic equation, just by looking at it, you understand, is that a standard form? Is that in factored form, or is that in vertex form? And then learning target number 2 says that you can relate the numbers in the vertex form of a quadratic equation to its graph. So just like when we talked about standard form, and we said the c term in the standard form was your y-intercept, just like we said that with factored form, I can set each factor equal to 0, solve for x, and find my x-intercepts. Now they're wanting you to be able to look at the vertex form and pull your x and y coordinates of your vertex right out of the equation that is in vertex form. We have one glossary term, and that is vertex form of a quadratic expression. And you can see here that the vertex form is a times x minus h squared plus k. And the only rule about the numbers for a, h, and k is that a is not allowed to be 0. And that's because if you multiply by 0, the squared term goes away, and this is no longer a quadratic expression. When you're looking at this, what you need to understand is that the h term is the x-coordinate of your vertex, and the k term is the y-coordinate of your vertex. Now, when you're doing this, most people find it easy to find the y-coordinate because it is plus k. So your y-coordinate is going to be exactly what you see. If you see plus 5, then your y-coordinate is 5. If you see minus 7, then your y-coordinate is negative 7. Where most people have difficulty is with the h term, because notice that it is x minus h. So your x-coordinate of your vertex is actually the opposite of what you see. If this says x minus 2, even though we see x minus 2, the x-coordinate of my vertex is going to be positive 2. If this said x plus 8, then that would actually be x minus negative 8, and your x-coordinate of your vertex would be the negative 8. So while we're working through the practice problems, I will make it a point to emphasize this feature as we are finding the x and y coordinates of our vertex. Now we can begin the practice problems for lesson 15. Practice problem number 1 says to select all of the quadratic expressions in vertex form. So let's make sure we remember what vertex form looks like. Vertex form is a times x minus h squared plus k. And that is exactly what a looks like. In this one, a equals 1. So even if you don't see a number in front of the parentheses here, you can understand that it's 1 because 1 times anything is just itself. Then we're looking for h. Well, h equals 2. Because remember, it's x minus h. And then k is exactly what you see. Since you see plus 1, then that means that k is positive 1. So a is in vertex form, and my vertex from this is going to be 2, 1. Let's look at b. b is x squared minus 4. Now, it might be hard to understand, but let's take a look here. What if I put parentheses around the x, and what if I put a 1 here? Or even better, what if I wrote 1 times x minus 0 squared minus 4? There's nothing different about what they gave us and what I wrote other than I added the 1, but 1 times anything is just itself, so I didn't actually change the value. And then I put a minus 0 just so that you could see the h. But if you subtract nothing, you didn't change the value at all. So now, if you just rewrite it like this, it's easier to see that a is going to be 1, h is going to be 0, and k is going to be negative 4. And my vertex would be at 0, negative 4. So b is, in fact, in vertex form, even if it didn't initially look like it. C is not in vertex form. This is actually in factored form. So the only thing we would be able to tell from this is that the x-intercepts, if x was equal to 0, then I'm at 0, 0. And if x plus 1 equaled 0, then x would be negative 1. So C is incorrect. It's not in vertex form. It's in factored form. We're not going to be able to identify the vertex from it, but we can find the x-intercepts. choice D. Maybe you can notice, maybe it's a little hard to notice, but D is in fact in vertex form. Because what I could do is I could put a 1 in front of the parentheses, because multiplying by 1 doesn't change the value of anything. And then I could put plus 0 at the end, because adding nothing doesn't change the value. And now you would be able to see that this is vertex form. And once you know that it's vertex form, you can identify that A is 1, H, because it's x minus h, this is really x minus -3. So h is -3. K would be 0. So I would be able to identify my vertex, which would be at the point -3, 0. So yes, D is vertex form. And the last one, E, hopefully you can see that it is in fact in vertex form. If you needed to, you could put the 1 in front of the parentheses so that it was easier for you to notice. In this case, A is going to be 1. H is going to be 4, because remember it's x minus h. And then K is going to be 6, which means, yes, we can find the vertex. The vertex would be at the point 4, 6. So E is in vertex form. So A, B, D, and E are all in vertex form. They all allow you to find the vertex simply by looking at it. C was the only one that was incorrect, and that's because it's in factored form, which allows us to find the x-intercepts simply by looking at it. If you have any questions about any part of this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 2. Here are two equations. One defines function m, and the other defines function p. Notice that function m is given to us in factored form. Function p is given to us in vertex form. Number 1 says show that the expressions defining m and p are equivalent. The easiest way to do this is to go ahead and expand them, or do all the multiplication and addition, or subtraction in this case, and turn them both into standard form. So on number 1, m of x equals x times x plus 6. Well, use the distributive property, and x times x is x squared, and x times 6 is 6x. Now we have standard form. Then we have p of x, which is x plus 3 squared minus 9. So that is x plus 3 times x plus 3 minus 9. Use the distributive property. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. And then we have minus 9. Well, you can combine the x terms, and you can combine the constants. So you have x squared, 3x plus 3x is 6x, and 9 minus 9 is 0. So now we're in standard form. And you can see they are exactly the same. Both standard forms are the same. Therefore, they're equivalent. Even though they are written in different forms, they will still have the exact same answers, and they will still be the exact same graphs if you were to draw them. Now, number 2 asks us, what is the vertex of the graph of M? Explain how you know. Well, M is in factored form, and factored form doesn't help us find the vertex. But M is equivalent to P, and P is in vertex form. So, use the vertex form of P of x h, since it's x minus h, this is really x minus negative 3. So h is negative 3. K, since it's plus k, then this is really plus negative 9. So k is negative 9. Therefore, the vertex is at the point negative 3, negative 9. So this is where it's helpful to understand that equivalent equations are going to have the same graphs. So they'll have the same features, the same vertex, the same x-intercepts, the same y-intercepts. So now for number 3, what are the x-intercepts of the graph of P? Explain how you know. Well, P is in vertex form. That doesn't help me find the x-intercepts. But M is in factored form, which does let me find the x-intercepts. And since P and M are equivalent, they will have the same x-intercepts. So we're going to use the factored form of m of x. And when we do that, we're going to say x equals 0. So the x-intercept is at the point 0, 0. And we're going to say x plus 6 equals 0, which means x must be negative 6, because negative 6 plus 6 equals 0, which means the other x-intercept is at the point negative 6, 0. So again, standard form, factored form, and vertex form, once you know they are all equivalent, you can change between the formats to find the points that you want, because they will all have the same answers, the same points, and they will be the same graph when you draw them. If you have any questions about this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 3. Which equation is represented by the graph? So what we know is that we know from looking up here that h equals negative 3 and that k equals negative 1. So if I were to just worry about that part, I have x minus negative 3 squared plus negative 1. So now we can write this as minus a negative becomes x plus 3, and plus a negative becomes minus 1. The next thing we need to know is that if opening down, then a is negative. So we need to put a negative out here where a would go. So I'm just going to rewrite that as negative x plus 3 minus 1. And if we look at our choices over here, C is the only one that gets this correct. A would have a vertex at 1, 3, and it would open upward. That's why it's wrong. B would have a vertex at negative, or at positive 3, positive 1, and it would open upward. So B is wrong. And then D would have a vertex at +3, +1, and it would correctly open downward. But it would be wrong because the vertex is in the wrong spot. C is the only one that correctly matches our vertex and the fact that it opens downward. If you have any questions about any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 4. For each question, write the coordinates of the vertex of the graph that represents the equation. So, looking at number 1, we can see that because it's x minus h, then h is +3. And since it's plus k, that means k is +5. So the vertex is at the point +3, +5. Number 2. Because it's x minus h, h is actually -7. Because minus -7 becomes +7. And then because it's plus k, k is going to be 3. So the vertex is going to be at the point -7, +3. Number 3. It's x minus h, so h equals 4, plus k. Well, there's nothing out here, so we can imagine that this says +0. So k is going to be 0. That means the vertex is going to be the point 4, 0. Number 4. We have x, and that is it. So imagine that this says x minus 0. In that case, h would equal 0. Then we have -1, and since it's plus k, that means k is going to be -1. This leaves the vertex at the point 0, -1. Number 5. We have x plus 1. Well, remember that vertex form is x minus h. So to get a +1, h would need to be -1, because minus negative becomes plus. Then we see -5, and since it's plus k, this would be plus negative 5. And our vertex is going to be at the point negative 1, negative 5. And finally, number 6, we have x plus 1. Vertex form is x minus h. So to get a plus 1, h would need to be negative 1 because minus negative becomes plus. And then we have minus 5. Since format is plus k, this would be plus negative 5. So k is negative 5. And our vertex is at negative 1, negative 5. Now, if you notice, the answers for number 5 and number 6 are exactly the same, but the equations are not exactly the same. The difference is the a term. On number 5, the a term is 2. Since it's positive, that means number 5 opens upward from this vertex. Number 6, since the a term is negative 2, the negative means this one opens downward. So 5 and 6 would actually be mirror images of each other, where they would share the same vertex and then open in opposite directions at the same rate. If you have any questions about any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Our last practice problem number 5. For each function, write the coordinates of the vertex of its graph and tell whether the graph opens up or down. So as we look at function f, if I want the coordinates, then I want h and I want k. It's x minus h, so h equals 4. It's plus k, so k must be negative 5 because plus negative would be minus. So k is negative 5. That means the vertex is at the point 4, negative 5. Now they want to know if the graph opens up or if it opens down. In this case, a, since we don't see a number, equals 1 and is positive. Because it's positive, that means it opens upward. Now we can look at function g. If I want h, I'm going to need to imagine that this says negative x minus 0 squared plus 5. So my h is 0. My k is 5. So my vertex is at the point 0, 5. Now we can see that the a term is -1. Therefore, this is negative. And if a is negative, then it opens downward. And our last one, because it's x minus h, then h would have to be -1, because minus negative becomes plus. K, we have plus k, so k would be -4, because plus a negative becomes minus. That means the vertex is at the point -1, -4. If we look, we see that a equals 2, which is positive. And if a is positive, then just like in number 1, this opens upward. So I hope that you have a better understanding of the vertex form of a quadratic function. If you have any questions about any of the practice problems I worked on this lesson, please leave a comment below and I'll get back to you with any help that I can offer. Before we end this lesson, let's go back and take a look at the learning targets just to make sure you learned everything you needed to from this lesson. So there were 2 learning targets for this lesson. These are the skills they're going to expect you to understand for the test. Learning target number 1 says that you can recognize the vertex form of a quadratic equation. The vertex form is a times the quantity of x minus h squared plus k. The a tells you if it opens upward or downward. The h is the x-coordinate of your vertex, and the k is the y-coordinate of your vertex. Learning target number 2 says that you can relate the numbers in the vertex form of a quadratic equation to its graph. This means you understand that if a is positive, the parabola opens upward. If a is negative, the parabola opens downward. Remember that it is x minus h, so h is the opposite of what you see, and h is the x-coordinate of your vertex. And then because you have plus k, k is exactly what you see, and it is the y-coordinate of the vertex. I hope you found this lesson helpful. On the screen, you should see a video that YouTube believes will be helpful to you. I ask that you please hit the subscribe button, give this video a thumbs up, leave a comment, and I look forward to seeing you in the next lesson.